right, so let's continue here with this review of section 4.1 of let's continue with this review of exponential functions from section 4.1. Now, what we're going to look at here is looking at application of exponential equations, which deals with finding the interest of investment at a certain interest rate that is compounded and many times per year. In other words, let's look at compound interest here. How to calculate the compound interest formula like you did in algebra. So compound interest. Oops. Okay, so recall this type of problem here. Right. If we have a certain amount of dollars, usually denoted by P, and these dollars are either being invested or borrowed at a certain amount of interest, right? So for P dollars invested or borrowed at an annual interest rate, denoted by little r, that is compounded and many times per year, that is broken up and many times throughout each year for T amount of years, the future value, how much this investment is going to grow to, can be defined, can be calculated using the following equation. Okay, so let's recall this. If we want to calculate how much an investment or a borrowed loan is going to grow to at a fixed interest rate that's compounded many times per year for T amount of years, to calculate the future value after T years, we use the equation of A equals, again, for now we're calculating the future value, so A is representing the future value. All right, after T years. Let me just make that note here. To calculate this future amount, we take that initial investment represented by capital P, and then we multiply this by 1 plus R divided by M, our interest rate, divided by the number of compoundings. I think that's a word, or compoundments maybe. The number of times we compound this interest by year. So R over M, and then raise this to the M times T. Okay, so to find the future value after T years, where T's are input variable, this is the equation that we use to calculate that investment. So our input variable is in the exponent, which makes this an exponential function. Okay, so before we continue, let me define these variables that we need to know here. Oops, let me do this instead. There we go. All right, so again, P represents the initial investment, or also known as the principal amount, or how much we're starting off with. The principal amount / present value. Okay, and R, little r here, represents the annual, keyword being annual here, the annual interest rate. And little m, again, represents number that is known as our compound value. The number of times we're going to break this this interest rate, the number of times we're going to break this interest rate throughout each year. The compound value, number of periods per year. And then T, and this is also key, this is also important to note, T is always measured as a number of years. Again, keyword being years here. All right. So let's do a little example here. Suppose that Zoe borrowed a student loan, or just say borrowed a loan of $1,000. Right, so borrowed $1,000 at an annual interest rate of 5%. It's going to be compounded quarterly. Okay. Given this information, given the amount of interest and the loan that you borrow initially, let's figure out what will be the future value. How much will this loan grow to? Or what's the future amount in ... the following years. For part A, let's figure out how much this loan is going to grow to. In other words, how much she's going to pay back in 2 years. Okay. So the first one, identify when these type of problems are these 4 values. We're going to be plugging them into our equation, starting first with the principal amounts, which in our case is $1,000. That's the initial, in this case, the initial loan. So P is going to be 1,000. Okay. And then we want to identify, if given, our annual interest rate, little r, which in our case is 5%. All right, so when converted to the value of r, make sure to convert it into a decimal number. So r will be 0.05. When we plug in r into this equation, we call that r has to be a decimal number. So if it's given a percentage, convert it to decimal before making your calculation. All right, so 5% interest. Now, M is how many times this interest is going to be broken up per year. And it's telling us that the interest rate is going to be compounded quarterly. Oops, that's the highlighter. Compounded quarterly. What does quarterly mean? How many quarters do we have in a full year? 4. This means 4 times. Quarterly, 4. Monthly, 12. Weekly, 52. And so on. Right, we look out for those keywords to determine what your value of M is going to be. So in this case, M will be we're going to break up this interest rate 4 times per year. Okay, and then for part A, we want to figure out, using this information, how much this loan is going to grow to in 2 years. So 2 will be our value of T. Okay, so here we have the information that we need, the values that we need to enter into this function. Okay, so let's set this up here. And since we're compounding it a fixed amount of times, then we have to use this compound interest formula. Right? If we know a value M, we have to use this equation here above. So A is going to equal P, which is 1,000, parentheses, times 1 plus R, which is 0.05 in our case, divided by M, which is 4, raised to 4 times 2. Okay, or in other words, I'll simplify this a little bit. 1,000, parentheses, 1 plus 0.05 over 4 raised to the 8. Now, if we're doing this, make sure to follow, when we're calculating this investment, when we're calculating this value here, make sure to follow the order operations. We got to first evaluate what we have in parentheses, then whatever we get on the inside, raise to our power on the outside, and then after we raise it to the power, then we multiply by this coefficient in the front. Okay, so you're going to take it step by step, do the inside first. What do we get there? Raise to the 8th power, and then multiply by 1,000. The only thing I want to suggest here is, when taking it step by step, make sure you're rounding to 4 decimals, at least 4 decimals if needed. Okay, but we can also just do this all at once using our calculator. And we got to be really careful how we set it up in our calculator if we want to make this calculation all at once here. Okay, so let's open up our calculator. All right, so parentheses are going to be your friend in this case. So first things first, our initial principal, which is 1,000. The left parentheses, and then we set up the grouping on the inside. So 1 plus 0.05 divide by 4. All right, 1 plus R over M. Close that right parentheses. Then we want to raise this, and we use parentheses here again, of 4 times 2. How we initially set it up. I'm going to use that. So for exponent, make sure to also utilize parentheses. So 4 times 2. Okay. So here we're going to do that calculation all at once to give us 1,004.4861. Now let me use 4 decimals here for this estimate. All right, so this is going to be 1,000. $1,104 point for the decimals again. 4861. Okay, but since we are talking about money here, then at this interest rate, that's going to be compounded 4 times per year. For this initial loan of $1,000, after 2 years, it's going to grow to $1,104.49. So we're talking about money. Let's convert this to dollars and round to the nearest cent. Okay, let's do the second part. And for the second part, for part B, let's see how much, this invest or this loan is going to grow to in, say, 6 months. Okay, in 6 months here. All right, so again, our values are pretty much almost the same. P is still 1,000. Our interest rate is still 0.05. M is still 4. But T here, what is T going to be for part B? Again, for this equation, for this formula, T is the number of years. It has to be in terms of years. But what do we have here? 6 months. So what we need to do is convert this value of months into years. We're going to make a little conversion here. Okay, how do we convert months into years? By taking the number of months and dividing it by 12, the number of months in 1 full year. So 6 divided by 12, 6 months is equivalent to 1/2, or in other words, half of a year, 0.5 of a year. Okay, and once again, use the formula and plug in what we know. So A is going to equal our initial principal, 1,000, multiplied by R, parentheses 1 plus R, which is 0.05, divided by 4, raised to 4 times 0.05 in this case. Okay, to give us roughly, let's see. Oops, not 0.05, 0.5. Half of the year. 4 times 0.5. Okay, so let's go to the calculators to make this calculation here. All right, so again, first start off with our principal, which is 1,000. The left parentheses, 1 plus our interest rate of 0.05, divided by 4, close parentheses, and then raise this, again, using grouping, using set of parentheses, raise this to 4 times 0.5. Right, to give us a future value of in 6 months of $1,025.16. Okay, I was going to round it to dollars already. $1,025 and round to the nearest cent, 16 cents here. So $1,000 or $1,025.16. Yeah, if we want to figure out the future value of an investment loan that we're taking out at an annual interest rate compounded how many times per year, then we have to use a compound interest formula defined as P times parentheses 1 plus R over M, raised to the m times t. Now, suppose we want to go the other way around. Suppose we know what our future value, we know what we want for our future value to be, and we want to figure out what should be our initial investment. What should be our initial investment or loan if we want that loan or investment to grow to a certain amount after T many years. If that's the case, if that's what we're trying to solve for, then we want to calculate the present value. Okay, so for a future payment or investment measured in P dollars that is being compounded at annual interest rate, represented by R, compounded n many times per year. All right, so for some future payment or investment that's going to be paid in T years, to be paid in T years, its present value can be calculated by using the following equation, which is kind of similar to the compound interest, except in this case, kind of doing the opposite. Here we know what our future value, what we want our future value to be. And if we want our future value to be this amount, we want to figure out what the present, what the initial investment or loan needs to be. In that equation, we'll still use A to represent that, but in this case, A is representing the present value. And this present value is calculated by taking our future amount represented by P, our future payment, future investment, and then dividing this, instead of multiplying, we're going to divide it by 1 plus R over M raised to the M times T. Pretty much what we're doing here is solving for that initial principle. We call for the compound interest formula to calculate the future value. It's A equals P times 1 plus R over M to the M times T. But if we know our future value, if we know what A is and want to solve for P, then we divide both sides by this grouping of 1 plus R over M to the M times T by the exponential part of that equation. That's essentially what we're doing here. To calculate the present value, to calculate the initial principal, we take the future amount and divide that by this exponential expression. All right, so just little notes here. So again, P in this case, instead of the initial principal, P is going to be representing our future amount, our future value. All right, R is still representing our interest rate, our annual interest rate. Again, keyword being annual. M is the number of periods per year, how many times we can compound it, or compound value. Periods per year. So pretty much everything stays the same except P here is representing the future value. And once again, T is a measurement of years. T still has to be in terms of years. Okay, let's do an example here. Suppose we want to figure out the following. Suppose we want to figure out what needs to be or what should be the initial investment if we want this investment to grow to $4,000 in 3 years, at an interest rate of 25%, which doesn't seem very likely for an investment to grow that much. But we'll use that at 25% interest compounded monthly. Okay, so let's define the variables that we need to know to solve for this problem. Starting with first, determine what our future value is going to be. So here we want our future value to grow to $4,000. Check everything's going good here on Zoom. Okay. So here we want our future investment to go to $4,000. So that's our value of P. That's our future amount. Okay. And then identify once again our interest rate. Our interest rate is 25%, so that would be 0.25. Identify the number of periods per year, our compound value of M. And in this case, we want to compound this interest rate monthly. Okay. How many months do we have in a full year? 12. So for each year, we're going to compound that interest 12 times. All right, and we want to figure out what should be our initial principal, our initial investment, if we want this amount to go to $4,000 in 3 years. So T is going to be 3 here, 3 years. Okay, so we have every component that we need to plug into this equation now. All right, so we can have A equals, all right, our future value, which is going to be 4,000, divided by parentheses 1 plus our interest rate of 0.25 divided by the number of compound number of periods per year, which is 12, close parentheses, and this will be raised to the number of compoundings per year, which is 12, multiplied by T, which in our case is 3. 12 times 3. In other words, we're going to take 4,000 and divide this by 1 plus 0.25 divided by 12 raised to the 36. Okay. And let's see how to calculate this directly using our calculators here. So again, we're going to be careful because now we got to be very extra careful because now we have a fraction here. Okay, instead of multiplying, we also included some division here. So using our calculators, let's see how we go about setting this up. So first things first, start off with our future amount, which is 4,000. Okay, divided by, and this is, we're going to be real careful. Let's put 2 parentheses, not just 1. Let's put 2. So let's put 2 left parentheses. And after the second parentheses, enter our grouping of the inside. So 1 plus 0.25 divided by 12. Close with 1 right parentheses, only 1 for now, because we want to take this grouping on the inside and raise it to 12 times 3, to our exponent of 12 times 3. And you want to be extra careful, just as we did before, put parentheses around your exponent. Okay, we want to raise it to 12 times 3, or we can just put 36 as well if you want. Make sure to come all the way back down, and then put a second right parentheses to close the denominator. All right, so again, 4,000 divided by 2 left parentheses, 1 plus 0.25 divided by 12, our grouping on the inside, 1 right parentheses, raised to our value of M times T, so 12 times 3. Come back down and put a second right parentheses to give us $1,904.08. Again, round to the nearest cent. So we're gonna have, so if we want this investment to grow to $4,000 in 3 years at a high interest rate of 25%, that's going to be compounded 12 times per year. Then our initial investments should be $1,904.08, roughly around that amount. Okay, so for the future value, if we want to calculate the future value, we use a regular compound interest formula. If we want to calculate the present value, then we use pretty much the reciprocal of that, where we have P divided by our exponential expression. Okay. Let's see. Let me pause this video and do one more part regarding section 4.1. One more example, and then the last item of interest in this section.